Hello, Marauders, skydiving here, and today we're going to learn how to do day 2 of geometry. Today we will look at drawing 3D objects. Yes, how to draw a 3D letter, how to turn these into these. And there's more than one way to do it. I'll show you some easy ways. And speaking of 2 dimensions, looking down here, we need to look at a few vocabulary items. Okay, so what is a prism? Okay, so when you see this, don't call this a square. A square is something flat. But imagine if you stacked up a whole bunch of squares, then it would become three-dimensional. When it becomes 3D, when you have a block shape that's 3D, we call it a prism. For example, here's a square. Now it's a square prism. We can actually call it a cube. Here's a triangle. We stack them up. Now I have a triangle or triangular prism. And here's a hexagon, but now it's a hexagon prism. Hexagonal prism. If you took a square once again, instead of stacking it up into a prism, if it came to a point, we could just call it a square pyramid. Likewise, here is a triangle, not a triangle prism, but a triangle or triangular pyramid. Some of these have their own fancy names, like this could be called a tetrahedron. Here's some more vocabulary. So these look kind of similar here, but they're all just a little different. If you have a dead end line, we call it a line segment. A segment is a piece of a line. If I say a line, we assume it goes forever and ever. Like I'm standing in line and it goes forever and ever. But if I just took a piece of it, that's a segment. You can even call it a line segment. If you have one that kind of looks in between, that starts somewhere and shoots in one direction, we call it a ray, like a light ray. Imagine a flashlight or a gun. It starts in one direction and goes in one direction. It starts in one spot and goes in one direction. So sometimes for short, when we write these, like if I got segment EF, for shortcut, we say EF and we draw a little picture right above it of a segment. We read line segment EF. If I said EF and drew a little arrow above it, like a ray, then someone's talking about you're starting at E and you're going this way to point F and right through it like you're shooting an arrow. So that's where the direction's important. And if this went forever and ever, and it wasn't a segment, we would just put little arrows on the end. Okay, parallel lines. We've learned about that before. Lines in the same plane that do not intersect. These never touch each other. Here here's parallel lines again. Just because two lines never intersect, though, doesn't mean they're parallel. That's something I would demonstrate in class. But this is true if you're on a flat piece of paper. But in the real world, you can have two lines that don't intersect, yet they're not parallel. Here's parallel lines again. Here's parallel planes. What is a plane? A plane is a flat surface, right here. A plane's a flat surface, like the ground on a football field, or a wall, or the ceiling. We call that a plane. So here's two parallel planes. Somebody could be like standing on one of them. There's a person, here's another person standing on one of them. So they're on like first floor and second floor. Here's some parallel lines again. Okay, so I got a line here, line A. And I put which line is parallel to line A? Is it B or is it C? Just because it looks parallel doesn't mean it is parallel. So how do I tell for sure? What do you think? Is it A or B? You can pause the video here and decide. All right, welcome back. They look close, but the only way to truly tell if they're parallel is to check the slope. This guy's slope, I like to go this way, is up 2/4. This drawing has it kind of underneath. Does B do that? Let's see. B goes up 2 and also over 4. It's also 2 and 4. That means it's parallel. C goes up 2, but it goes over 1, 2, 3, 4, 5. Uh-oh, this one's up 2 over 5. It's a little bit off, but these two are parallel. So that brings us to the definition of, can you draw a parallelogram? What is a parallelogram? Here's a parallelogram. A parallelogram has the opposite sides are parallel, but so are these two. These ones are also parallel. If everything's parallel, top and bottom, left and right, then we call it a parallelogram. One way to label it to tell people that you did it perfectly parallel is people put little arrows to say these two go in the exact same direction. That's the symbol. Likewise, this goes in the same direction as this one. But wait a minute, how do I know that these two aren't the same? So what we're going to do is, since I already used 2 little lines, let's put a third line. That way you know the ones with 3 go with 3 and the ones with 2 go with 2. That's what a parallelogram, opposite sides are parallel. Something else that's neat about it is if you measure the length of this side is the same as this side. See how I marked it? I didn't put an arrow, I just put a little dash mark. That means these go together. Likewise, this goes with this, but wait a minute, I'll use 2 lines to say that those go together, so you match them up. If you wanted to, you could use 3 lines and say those go together. So in a parallelogram, the opposite sides are the same length and they're parallel. There's some other cool things about it. Like this angle is exactly the same as this angle. The opposite angles are exactly the same. Likewise, this angle right here and this angle right here, they're the same. Sometimes we put little marks like that to say these two go together, and we could say that this one goes with this one. Maybe I'll use 3 little marks and say those go together. So parallelograms are pretty interesting. Next page. Okay, now we're going to try to draw 3D letters. So I'm going to do this on a piece of paper. Okay, so the secret to doing 3D letters or any 3D shape is to use parallel lines. So if I drew something simple like a rectangle, one way to get this to turn 3D is pick a corner, any corner, like this corner, and go in any direction you want. Maybe like that. You can go any length you want. Now, go to another corner and draw the exact same thing you did. You have to go in the same direction. You can't be crooked. You have to go exactly the same direction and the same length. The same here. Same thing again. All 3 of these are parallel and the same. Now, you could go and connect these corners. And one thing you'll notice also is that this and this and this are parallel. All of these are parallel. If you don't get it parallel, you're going to have something funny looking. Like if I was sloppy here and went like this and then went that way and this way, and then made one a different length, you're going to have a real mess. First of all, look, this and this are not parallel. So parallel, everybody's parallel. Some people do a different way. They draw it originally, and then they draw it again over here. Make this the same, and then they go back and connect them. Every one of those should be the same length. So let's try with a letter. I'll try the letter like A. Okay, so I'm gonna make a block letter A. So here's a block letter A. So make it blocky. And so now I'm gonna make it 3D. So once again, pick any corner. You can go in any direction you want. You could go down, but I'm just gonna go to the side. You can go any length you want. And we'll go like that. So I do the same thing. If you need to get a ruler to measure that, you can. So it's exactly the same. Do it again right here. And in fact, while you're at it, when you connect this, these should be parallel. I'll do it in blue to show that this goes with this, parallel. This side, see how this is going like this? This needs to go exactly parallel. So those are parallel. I'm going to mark on it with a little pencil. In other words, you notice this is parallel to that. Likewise, this is parallel to that. Is it totally done? Wait, I could do this piece right here. Looks like it's missing something. Let's do in here. Actually, I run out of room. So we'll cut off there, and you can even put them in here anywhere you can. And there it is. Now you can go back and even shade it. If you decide to shade, like say you want to shade this side, then match this side with this side. Anyone that's going the same side, that looks like this piece right in here. And now you got a true 3D block. It doesn't include what we call 1 or 2 point perspective, but it is 3D block. So you get to try some now. Okay, I'm gonna do one more letter, but this time I'm gonna do letter with something rounded. You might wanna do your initials. So let me try something that's rounded like the letter P. Oops, I didn't make that block. Well, I can fix this. So let me start this guy over. I forgot to make him blocky. There you go, there's a letter P. So to make him 3D, again, I'll go like this, any length you want. No, wait a minute, that's rounded. I could do this part. I could do this part in here. And now what you're gonna try to do is draw a parallel to the curved line. In other words, follow this and then match it. But you go, wait, how far do I go? Where this curve goes, you're gonna get right to this edge. It's called this a tangent line. So this matches. So you come right off that edge. All these purple guys are parallel, and then this, curve him out. And then there you go. And then, oh wait, we gotta do this guy parallel right here. There you go. And there's kind of your 3D looking P. If you wanted to shade part of it, you could shade maybe like the top surfaces and color it off a little. Okay, let's look at this slide. This is actually the beginning of the homework. You're gonna be doing numbers 2 through 8, and here is number 2, so I'll guide you through a little. In the block letters that you can draw by following the recipe in the lesson, which faces are parallel? Okay. Why would you normally shade parallel faces the same way? So here's what I'm kind of thinking. Under what conditions would you shade them differently? What is the secret to that? Why would you shade parallel faces the same way? Well, number 3 kind of goes with it. Number 2, it's kind of like, how do you kind of answer it? But let's look at number 3. I want you to check out this drawing right here. What do you see? There's 2 here. Okay, so what is it a picture of? Let you think about it. Some people say it's a box in the corner. Is it? But other people think they see something missing. In other words, I'm going to actually make this for you. Some people see this. They see a block in the corner. Well, other people see this, a block missing a corner. Which is it you see? Let's go back to the picture. Okay, so here's our drawing. Is it a block in the corner? Watch this. Now what do you see? I'll do that again. It's here. Now you might be confused. What if I took this little man? Some people say, it's a guy sitting on a block in the corner. But if I spin it around, now is it a block in a corner? No. Some people say it's a guy sitting on a little cutout. Likewise, I could take this guy and put him right here. How many cubes are over here? Some people say, well, there's 1, 2, 3, 4, 5, 6. I see 6 cubes, I can sit on them. Yet if I turn it over, here it goes. Now how many cubes are there? Wait a minute, I see 1, 2, oh, we lost our guy. 3, I see 3 cubes inside of a room. So why does this happen? The trick is, it's the sun. That has to do with number 2 and 3. The sun makes the shadows. So when we see stuff, we imagine the sun's in the sky because this is how our brains work. We imagine that this top surface is where the light is hitting. In other words, right here is a lighter surface. That's because the sun is shining down on the sides that are facing up. Too much. Okay, so, nope, that doesn't work either. So notice that like this side is dark and so is this one because they're in the shadows. The sun's shining from this side. It's not hitting these. That's why we colored the same faces facing the same direction, the same color. So it's the same over here. So that's also why when I turn the picture over and rotate it over, your brain is saying, wait a minute, now it looks a little different because here's the sun. And once again, the sun is shining on the tops here, making these light. While over here, this side is dark because the sun's over here. And that's what creates the illusion. So that's 2 and 3. There's not much for you to really write down for 2 and 3. It's more of a discussion. But okay, you can do number 4. Once again, you're going to choose a letter, make it 2 inches tall, and try to draw 3D. Next slide. Okay, number 5, okay, 3-dimensional solids. Okay, that means like a cube or a block. Solid is like a prism. A plane of symmetry is where you slice it right in half. Many things have 2 sides. Here's what you do. Find 5 different symmetrical objects around your house, such as tissue boxes, cans of soup, and so on. Describe the planes of symmetry. In other words, remember we did line of symmetry, like you had the letter A, and you decided like, oh, I could cut it right down the middle. Well, how would you do it with a 3D object? So if I had like a tissue box, I'll draw, here's like a box of Kleenex, a little hole in the top. Where would you slice it to make it look like it's cut right in half? You probably could say, well, I would slice it right through there. So how do I do it? Well, I kind of draw like a big blade, chopping it right in half. Where would I chop it right into? I could cut it right there. Is that the only place I can cut it? No. I could also cut it the other way. I could have cut it this way, top and bottom. I could have cut it this way, left and right. I could have cut it 3 different ways. So you try to find some objects around your house that are symmetrical. Normally I would have you guys bring an object in, we share them. That's number 5. Number 6. Okay, this is a neat one. Okay, there's a little thing in here at the bottom for you to figure out. I can't see the bottom. So 1 second. Okay, so here, and in case we can't see this, is a little hidden here. A plane is infinite. When we talk about a plane, we're talking like a flat surface, like a piece of paper or the ground. When we say it's infinite, it goes forever and ever. And imagine we had a flat surface one forever ever. If we drew a line through it like this, you divide it into a region here and a region here. Another 2 regions. Here's region 1, here's region 2. Like you could be standing on this side, someone puts a big line right here, and your friend is standing on this side, like on the other side of a fence. Okay, and what if we drew 2 parallel lines? Now we've got 1, 2, 3 regions. If you're in between the lines, some people call it an interior region or an interior strip. Here's an exterior and an exterior, but 2 lines can make 3 regions. But what if we actually made the lines cross? Then we could have 1, 2, 3, 4 regions. Imagine a playground and you put a fence here and here, you could divide it into 4 areas. So here's the question for number 6. It's really down here what I want you to do. With 5 lines, if you drew 5 lines, what is the maximum number of regions in which you can divide a plane? It's not 10. This is like the pizza problem you guys did where you're trying to slice the pizza into many pieces. What if I gave you 5 lines? I'll give you an idea here. Here's the trick to make this pattern. Follow along right here and you get to finish it. If I made 1 line, like here, you get 1, 2 regions. If I made 2 lines, This one's not so good, but this is pretty good. 2 lines, I could get 1, 2, 3, 4 regions. What about if I did 3 lines? Well, let's see. 1, 2, and the trick is when you put the third line, make sure you hit both the other lines. Do not go through the middle. See, I missed the middle a little bit. I should do that even a little better. Let's make it a little extreme. How about right here? So always make sure you hit all the other lines. Don't go through a previous intersection. So I got 1, 2, 3, 4, 5, 6, 7. Okay, now I could try 4. Okay, where should I put this next line? The trick is to try to hit the other lines. So when you put it, don't go over here, that's not too good. Try to hit every line that you just did. So maybe if I went here, not down here, but I'm gonna hit 1, 2, 3. And now I've just created a few more regions. I'd have to recount them again. There's 4, 5, here's 6, 7, 8, 9. I've got to really recount this again. Whoops, too much. I'll have to erase this out. I'm stuck with that line. 2, 3, and then hit all 4 of these. And now you can count the regions again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here's 4, 11. Okay, so now, what if you did 5 lines? That's your question. If you had 5 lines, how many regions do you do? If you want, go for 6. Okay, that's number 6. Next question. Number 7, this is done with planes. We're gonna skip this one because it's kind of hard to do the pattern. So we're gonna skip this one due to our time. And lastly, here's number 8. You can just read the question. It's a multiple choice. And here's where you get credit. On the assignment, where you type in the text box, tell me your answer to number 8. You type in what letter it is. And that way I know that you at least got this far in the video. All right, so you guys finished the homework. The other assignment will show you the answers.